By 2020, there will be 250 million connected cars, connected vehicles on the roads, as per a study by Gartner. While connected cars, autonomous vehicles will solve a lot of problems of congestion, traffic congestion in major cities, will solve safety and security related issues, they also pose some significant problems. Some analysts feel that there is a possibility that hackers could take control of cars by hacking into the computers in the car, accessing the computers and the electronic control units, diverting vehicles, and cause significant damage.
Right.
Also, there is a possibility that hackers could also access the data within a car and use it for their benefits. Welcome everyone. My name is Sushav Wadekar, and I would like to invite you to the second of a three-part webinar series on the software-defined car. I am the Associate Vice President of Engineering and R&D Services for HCL Technologies, and I'll be your host for the next 60 minutes. In the previous webinars, we talked about how to monetize the software-defined car with aftermarket revenue opportunities. But how do we secure these connected and autonomous cars? That is exactly what we are going to talk about today.
Right.
Today's webinar topic is on securing the software-defined car using artificial intelligence and over-the-air updates. In the key speaker's role, we have Mahbubul, the CTO and CMO of Movimento, a Delphi company, and who is really a visionary in this age of the software-defined car. Through the course of the webinar, you will understand what machine learning is, how it works, and how we can secure the software-defined car with artificial intelligence and OTA updates. Before we dive in, here's some information on the format of the webinar. It'll be for 60 minutes with about 40 minutes of core content, right? And through the presentation displayed on your screens, followed by 20 minutes of Q&A at the end. We have some stock questions, and we'll take some questions that come online as well. Please send us your questions via live chat, and you will find visible on your screen, and we'll answer them at the end of the webinar. Without much ado, I would like to bring Mahbubul, an international entrepreneur, technology, and business executive, currently driving the evolution of tomorrow's vehicles as CTO and CMO of Movimento, to take over and help us understand the age of the software-defined car and how we can secure the software-defined car using artificial intelligence and OT updates. Mahbubul, over to you.
All right. Thank you, Sushav, and welcome everybody. So as Sushav talked about, we're going to talk about securing the software-defined car using artificial intelligence and over-the-air software update. We already got a great intro of Sushav and myself. So with no further delay, let's go into the content. What are we going to talk about? So first, I would like you to, like us to examine the state of the security today. Security industry is a multi-billion-dollar industry. Lot has happened. It has secured us in many different ways, but there are still many challenges. And what are those? Then we'll talk about the cyber risk, and that will be around threats and impacts from those threats. And from there, quickly we'll dive into what is our security architecture. What kind of security architecture do you need for a software-defined car? That is the foundation on which connected vehicle to autonomous vehicle is built on. And from there, we'll talk about the best practices of security. Then we'll shift gear to go into artificial intelligence and give an intro of artificial intelligence in terms of what are we talking about artificial intelligence, where do they fit, and what are the different categories, what are the different techniques. And then what we'll do is we will bring it all together to the security need and the artificial intelligence and over-the-air software and package it together to provide what should be a potential way of solving these emerging security threats and the impacts that we see in the industry. And then finally, I will do a key takeaways. And then I will hand it over to Shushev to go over Q&A. Hopefully, you will have a lot of great questions live, and looking forward to this amazing interaction. So, with no delay further, let's look at the security solution today. And what I'm going to do is reflect back 2 decades, solutions that we have since 2000, and what are the challenges even today in 2017. So in the 2000, the networking, connecting the internet and networking was a big deal and has still been a big deal, but we have solutions like firewall. If you look at firewall, yes, it has evolved a lot. It has become much more sophisticated, much inline processing. It is able to do a lot of access control and ingress, egress, a lot of different type of things. Continues to evolve in firewall, but if you look at today, even today, the auditing is a challenge of firewall. It has not solved in terms of what are the, what is whitelist, what is blacklist, what is access control. So firewall challenges are still there today. If you look at the intrusion detection and intrusion protection system, still too many false positive. The danger of that is if you it's like a crying wolf. Then after a certain moment you say, well, it's probably not right. So you have to find this right balance. So the false positives are creating a lot of alarms and events are being detected. So it's very difficult to manage this IDS and IPS solution. Then we have concepts since 2000, things called threat intelligence. Well, actually, it's an enhancement of IDS. It's just more signature based, more digital signature based, and better detection and prevention solution, but it still has the same false positive syndrome. Then you have data loss prevention. Well, data loss prevention is also another form of IDS offering. Intrusion detection, it could be intruding from outside to in or from inside to out. So data leaking out is another form of IDS extension you could think about. So the thinking, what I'm going about is that thinking level is still in the same way of looking at firewall, intrusion detection, intrusion prevention, or data loss, all around the same way. Whereas our threat vector and the attacks and the security breaches are skyrocketing. Things that are happening on the application layer and so on, like phishing and so on, are continuing and exploding, but we are still thinking the same way, antivirus, anti-malware, but it's not really resolving. We have a great system called, the industry has security information and event management. Sometimes it's called security information management SIEM, sometimes it's called SIEM, and these are a comprehensive orchestration way of looking at the entire security solution. But still the challenges with parsing and context related, what really happened at that moment, to understand the context around it has been and still is a challenge, and prioritizing them. Which one is more important than other? Vulnerability scanning, same, the vulnerability scanning is around network interface, APIs, and so on. Well, the speed and feed of the network has changed, but it's still the network interfaces are pretty much the same since 2000. It's Ethernet, wireless LAN, and so on. So from that perspective, it has not evolved from how we look at the things. And then security analysis, well, it's just another way of using the same SIEM solution, but in this case of security. Short message, we are still thinking from networking, data, information security, whereas the threat vectors and the challenges that are there today has evolved all the way from networking to more of the application oriented and so on. And if you look at it, really that the risk has not diminished. In fact, 96% of the security professional believe in 2017 that the security risk is going to continue to explode and exponentially grow over the coming years. So the security experts are not feeling at ease at all. So all the solution that we have is not reducing the risk. It's actually, they're saying it's going to continue to increase. So what should be our thinking? So in order to understand that, let's now take a look at from the networking information to automotive, and let's look at the cyber security risks. And what I have here on the left hand side is attack vectors and the potential outcomes. Phishing. Verizon's latest report of 2017 pointed out that 43% of the data breaches happen through phishing. And phishing has been on top of the news, whether it's about the government election or about intelligence agencies being hacked. Phishing is still being almost half of the data breaches, and that leads to credential and data theft and so on. DNS spoofing, very well known. If you can spoof the DNS, you can cause it to divert your traffic to some other directions and therefore cause a poor operation. So it has an operational impact. Denial of service, well, that is important. You could be a genuine, legitimate user and authenticated, but you could be asking and sending messages that are not much more meaningful. And on the other side, on the receiving side, it could be trying to figure out what those messages are, and that could overrun the buffer and thereby cause a denial of service. And if you do it from multiple authenticated users, genuine users who are authenticated, but you have some script that is running on your device and sending all these messages requesting for some information that doesn't make sense, you could cause a distributed denial of service attack. This is an interesting one, laterally moving malware. Now, it's great to have an application, but now the malwares have become much more sophisticated to move from one application to other application. We are a lot of the time running on the same hardware. All are virtualized or app-based, container-based, and we think that they are really isolated, enclaved in their own way, but reality is actually they can laterally move from one application to another application, and thereby the malware spreading from less sensitive to more sensitive or different set of security profile application from one to the other. So this can create a huge potential around ransom and hijack. Now, a word of caution here is the ransom is what we are seeing these days. It's very time sensitive. So it's not that we cannot detect it. Yes, if given time and so on, we probably detect it and we can, or as IT, you could say, oh, let me shut down the server, let me replicate it and in some other server. But the people who are holding your ransom, then this ransomware and with this ransom technique, what they will say, they know exactly how much time you need, and they're going to give you a very short time spent to pay or whatever they want you to do. Otherwise, they will release those information of your customers or your password and so on. So it's a very time sensitive thing, and that's the challenge. How do you react within that time? Location spoofing. This is being on the news in different ways, whether it is in the naval space or in terrestrial world. If you spoof the location, you could fool and trick the vehicle to think it is somewhere else, and you could ask it to go somewhere, and the vehicle is thinking it's coming home, but it's going somewhere else. So vehicle theft is definitely a possibility, and one could think of something else as well. Beyond that, OTA retasking. So when you do an over-the-air software update or a delivery, right? So you could intercept that if it is not properly secured, and then retask it to do certain thing. And it could be as evil as image recognition. You could mess up the image recognition, that it doesn't understand the biological or living things, and you could cause it an havoc, and all sorts of terrorism situation could come into place. And this could happen from your garage in a Timbuktu in some other country or some other land where we do not have our jurisdiction or our law doesn't extend to there. So all these capabilities are there, and Shushev talked about. These are the challenges of a connected car and the things that are still unsolved. So to address that, we come up with a concept called on and off board secure connected car concept. And here we bring a concept of 5 C's. And this 5 C's starts always with the silicon, the chipset. That's the foundation of where things are. From there we go to the client. Then from there we go to connectivity, and we'll talk about connectivity on and off board. So what it means, the silicon in the car, the chipset, the software, and the connectivity within the car, that is on board. And off board is when those connections go outside of the car through the wide area network connection to some cloud. So we have to look at both of those. Then we have cloud, we talked about, but then we also talk about fog computing. This is intelligent edge computing. When you do a lot of those computation and intelligence within the vehicle, then you have a situation of fog computing. So you have to think of both fog as well as that is within the car, and when it leaves, how to secure that infrastructure, but also from the cloud as well. And then you have the content. Content can reside in the car, content can reside on the cloud or behind the content provider that connects to the cloud for the OEM. So you have to think about these 5 C's. And if you look at it, these are some examples. In the chipset, at minimum, you should think of trusted platform module or hardware secure module. This is where you can store your secure key management for private keys, right? So this is a very important area. And then you have also certificate X.509 certificates and so on. So you should think about some hardware secure module where you store those. If you look at the client, you can think about this, just one example. This is not the only thing. It's about code obfuscation. And this is where basically you hash the client code so that it's asymmetric, so you cannot reverse engineer what the client code is and manipulate with that. This is just another one example. I'm just showing some of the example of how to think about it. If you think about connectivity on-board and off-board, you should think about in-vehicle network security, as well as the security between the vehicle and the cloud. So transportation and session securities are some of the obvious things that comes to mind. When it comes to cloud, whether it's outside, or fog computing, which is inside the vehicle, intelligent edge computing, fog computing, you have to think about secure virtual infrastructure. How do you secure it? It's literally the vehicles are becoming a mini data center or a mini cloud, a mini or a fog with wheels. And so you've got to secure those infrastructure. A lot of your information, whether it's algorithm or privacy data, all sorts of information are residing over there. And content, whether it's in the car or whether it's outside in the cloud, you got to secure the application. So this 5C concept is how we think about security. It's not only in the car, it's all the way from the entire supply chain of software, from the content to the cloud, to the through the connectivity, and it could again be the cloud, which is fog, and then connectivity of the vehicle network, client, and the chipset. So this is our 5C concept. So from there, if you look at it, we have been talking about this concept of software-defined car. What makes it a software-defined car? It's not just an ability to update software. If you look at the software-defined car, what we're going to do is we're going to zoom into the car, within the car, and we have what we look at is a 4-layer security stack. And what are those 4 layers? You need to think very differently about this. If you can see clearly, there's behind the car there's a software car, zeros and ones, and it has 4 layers. And from top layer you have the user experience, then you have the artificial intelligence. This is the data, a lot of data. Then comes the software, and then comes the firmware that connects to the hardware. All these are different types of applications and implications. So for example, user experience, you have to think about the application we talked about. Why should you think about that? Well, just take, for example, map, right? If the coordinates of the maps are unsecured, the car is going to think something else, right? You are doing a GPS spoofing or location spoofing, right? So you could fool it. If your media has a lateral moving malware, it could move from there to some other application. So you have to, your user profile has to be there. If you have an autonomous car, you might have productivity applications in the car, which could be your emails and conferences that connects to your office. Now, if a malware, that laterally moving malware, penetrates into your productivity tools and you are secured with your office, then suddenly you have, as a trusted person, genuinely not meaning any harm, as this is called an insider attack, you could potentially insert some malware back into the corporate network because it's there. So you got to secure the user experience, user application. On the artificial intelligence and the data side, absolutely should be very clear to everybody. A lot of algorithm, a lot of algorithm modifications will continue for foreseeable future. the autonomous vehicle era has not stabilized. It will continue to get updated on a regular basis. So the algorithm, image recognition, cloud sourcing of all those information from different autonomous car and disseminating all those things, 3D maps. So obviously securing this sort of things will also require a different way of figuring out how we protect this artificial intelligence layer. Software, I think, speaks for itself. The operating systems, the gateways, the domain controllers, and so on. This is with a software update or security patch. You can fix some of those vulnerabilities, known vulnerabilities today, or known vulnerabilities that you will come to know in time. Firmware definitely connects directly with the hardware. It allows you to reconfigure how a hardware operates and so on. So you need to also secure that. So this 4-layer architecture within the vehicle is how we look at security and role of the update capability, which are very different from firmware, software, data, and algorithms to applications. So that's within the car. Now we just talked about it, the 5 C's. We said, let's look at within the car, but also it's not enough to look within the car. The car is now suddenly connected to the something else we call off-board of the vehicle, which is cloud, and the content provider and service providers and user profile and other applications that are residing in the cloud, and this is known as the connected services that's going to come into the car. So how should that architecture look like? So on the very left hand is that car. You can see probably the car. That was what we had in the previous slide, zoomed in, right? Now if you just now look at the car, in order to secure the car, you've got to think outside of the car as well. So you got to think about what connects to the car and the whole supply chain of the content and the software that comes into the car. So what you require is first and foremost the ability to have a closed loop architecture. Your ability to collect the data from the car. The car is talking, it's giving out all sorts of information, whatever is happening. You need to be collecting it in a sensible way. You make some local decision with the fog computing, but some of those you need to send it back to the cloud for further analysis, and then the car has the capability of analyzing your messages and in relation to all the other messages that is getting from the other autonomous vehicles as well, and then be able to, you can find either a software update or a security patch or something that you want to modify. You can then push it back into the car as a secure over-the-air delivery. So this ability to collect the data, analyze it, whichever way you do analyze it, and then react back is a very important way how we can continue to evolve the journey towards the autonomous vehicle, which is the software-defined car. And you can see in the cloud on the right-hand side, behind that you may have a lot of suppliers. The software bill of materials are coming from different supply chain. You have content provider, you have application provider, all those sort of things that are coming through that through the cloud and back into the car. So this concept of closed loop architecture is a must. So it's not good enough to connect the car and then say, oh, I'm downloading some music and user experience. No, you have to have the ability to collect the meaningful data and then close the loop. And then only you have a system that is designed to evolve with time and also improve and also gain the human trust that it can learn and improve. So this is a concept of closed loop architecture that we talked about. So now that we talked about in-vehicle architecture, we talked about outside of the vehicle architecture and end-to-end, let's take a step back and go into what artificial intelligence is about. Because we talked about how artificial intelligence can help to accelerate and to be more proactive in terms of the security vulnerability. Because one of the challenges is ransomware, which doesn't give you, or ransom, which doesn't give you much time to react. So you need to be proactive. You have to act before it happens. So let's go into the basics of artificial intelligence. And what I'm going to describe is the 3 categories of artificial intelligence. And I think it's a common knowledge, but it's good to remind people. So first one we'll call it is known as artificial narrow intelligence. So narrow intelligence is actually where the machine intelligence for a specific task is greater or equal to the human efficiency. a specific task. So if you think about it, self-driving car or autonomous car is a one specific task. It just drives, and hopefully it will cause less, the statistic has shown that over 90% of the crash are human error, so hopefully it will help reduce those. So obviously if it can drive, that's the journey we're going towards. Self-driving car will reduce human errors and accidents. That would mean that specific task would be greater or equal to the human efficiency of driving, only driving, not anything else. That it will be classified as a narrow intelligence. Another example of that would be your Siri that does a certain thing, or some bots that responds to you. These are all about very narrow specific. The next level is called artificial general intelligence, and general intelligence is where for any task, the machine intelligence is going to be greater or equal to human intelligence. We're not there. It's going, some work are going over there, but it's getting on that. You might have seen that robot Sophie recently on the news. That can answer all sorts of questions, humor to everything. So where you are beginning to see that it can do all sorts of tasks, greater or equal to. It's not there yet as greater or equal to, but it's heading towards that. That's the whole idea of artificial general intelligence. Obviously after that comes artificial super intelligence. This is where machine intelligence for every task is going to be greater than human intelligence. This is where the society is concerned about. This is where all the discussion about ethics, should artificial intelligence have ethics, should operating system for artificial intelligence of ethics, should we have a governance as to what and what not. So this is where we are worried about of the future, but there's a long way. I think today and for a long time you will see the role of artificial narrow intelligence playing more and more critical role in your daily life, whether it's from self-driving car to the vacuum cleaner in a home to virtual personal assistants that is getting better and better. So this is where we're going to go into that. Now let's zoom into what artificial intelligence is. So all those are different categories of artificial intelligence, but what is artificial intelligence? If you look at it, there's a family of artificial intelligence. A lot of words have been, lot has been said about it. So all I'm trying to do is very simplify it in a very simple way. If you look at within artificial intelligence, we talk about machine learning. Machine learning is ability to learn without being explicitly programmed. Now, if you program everything, then you have events and you have thresholds and so on. So we have done data analytics and so on. But when a lot of things are coming at you, when all these complicated systems are generating so much information, so much events, so much alarms, you cannot explicitly program everything, whether it's security. So you need to make sure that you can your system can proactively take some action. So this is where you don't need explicit programming. Then it comes neural networks, and this is basically mimicking the human brain and neurons. So basically, if you look at in a nutshell, there are different neurons that picks up different things, and each are different neurons, and then you put it all together and you make sense out of it. So it's a multi-layer approach of hierarchies of detection that leads to something. So much more granular then. And this is where the deep learning comes, helps a lot. Basically helps you to learn about patterns because you are looking at the images. And this is, if you think about it, things like a lot of you might have used photos, recognition of photos and giving them names. And in the beginning you have to, it asks you a lot of questions and you say this is the same person in different photos, and it gets more and more intelligent, and then in a complex situation it can start detecting. So you don't have to know everything. So pattern recognition is very difficult. It's like your eyes, there are multiple layers of detection, and together it forms the comprehensive picture where you can make a decision. So that's what deep learning is about. So this was just very basic of deep learning. But if you look at machine learning, really the photo tagging, the targeted ads, the speech recognition, the preventative maintenance, all these are part of machine learning. So why don't we dive into the machine learning a little bit more? What is machine learning? It's in a very nutshell, you have a trained data. You have a data for which you know the input, and you also know what you want output. So you have labeled those data, and you find an algorithm that gives you that outcome. So when you find that algorithm, then you put it into a real data, streaming data that you don't know. So you have not labeled it. You do not know that, and this is the learning model that you create, and this algorithm is helping to predict the outcome. And this is basically in a nutshell. And you can decide whether you want to take some of the feedback back into the data. We'll talk about that. But in a very nutshell, that's what it is. You figure out a trained data. You come up with an algorithm that works for that. You use that algorithm in the machine learning, and then you have real live data, and the machine starts predicting. Obviously, you can understand from it, more data you have, more and the decisions that you're making, prediction. These are augmented artificial intelligence. So at the end, the humans are making decisions, and those decisions are getting back into the model automatically, and the models are putting different weight factors for different decisions the human made, and thereby the model becomes better and better. And that's hence the machine learning. So now, if you think that's there, but let's just demystify the machine learning a little bit, because we're going to use that machine learning back into our security down the road. That's why it's very important that we put this machine learning, the 3 categories of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We talked about the ability to reinforce. So if you look at the very right one, is learned based on the feedback and reverse. So you tell the machine, this is right, this is wrong, and the machine is tweaking its weights and getting better and better, the model. But let's focus on the left two, supervised and unsupervised. So supervised is a very simple learning with a label train set. So you have a label data and you have trained it. So what does it mean? It is great at predicting things. Whereas the unsupervised is discovery of patterns in unlabeled. You have not labeled it. You are just getting it, and it's learning on. So what it happens, it's going to be more of the descriptive. So it's going to describe certain things. It's not going to predict accurately, but it's going to describe and create some cluster and groups and so on, so that it makes it easier for humans to make decisions. So let's zoom into this supervised learning and unsupervised learning a little bit. So if you look at supervised learning, I talked about, it's about predictive, right? Predicting it, because you have trained data as the base on which you build the model. Unsupervised was descriptive. It's untrained, unlabeled, and it's going to figure out. So if you look at predictive, you have classification as one of the subcategories of that. And classification is, simply you take a document and you start classifying all the things that are related to security in one category, all the things related to OTA another, all the things related to software-defined car. So throughout, it can parse out this huge document and start putting things into some categories. It's great benefit in classifying things of large amount of data. Don't think about document only, but think about tons and tons of data. Remember, a autonomous vehicle if you look at the amount of data it collects, anywhere between 4 terabytes and more per hour is generated through computer vision, LiDAR, radar, and so on. So categorizing them into different segments could be of great help. Regression, this is very well known and has been used in financial industries and other places. You have lots of data. You find you find an equation. You find that fits that data, that describes those data as best as it can. And if you have that, then you can use that algorithms and that equation to predict some of the future. So that's regression analysis has been out there for a long time. But what is interesting in this case is, unlike the analytics regression, here the weight factors are adjusted by itself based on what kind of decisions are being made. Let's look at unsupervised one, and this is about clustering. So I talked about, you have group of things that is unlabeled, you don't know anything, but it helps you to cluster into different categories, and thereby you can now start focusing on each cluster, and helps you to segment them and be a little bit more focused. Anomaly detection is also well known in the industry. Is just finding an anomaly. You have a value and you have an anomaly that comes up. But unlike static, with machine learning, these are dynamic. In other words, it's seeing how you are behaving to those, what kind of actions you're taking, and these values of threshold, what is anomaly or not, are going to change with time. That is what is interesting. So we're moving from a static analytics to more of the dynamic and machine making, those dynamic decision to help augment and help human make those intelligent decisions. So it's augmenting intelligence for human to make those decisions. That's what makes machine learning so interesting. Now, just a very quick word, since we talked about machine learning, obviously on media and everywhere, there's a lot of talk around deep learning, right? So let's basically, I think I described it very clearly. Deep learning is mimicking the human brain using neural networks. It's about multiple layers or multiple hierarchy, and each one detects something, and then together you bring all those so that each one focuses on one particular segment. One may be on the light, one may be on the curvature, one may be really on the eyes. So there are different specialized filters or layers you can think about that specialize, and then you combine them together, and then you make a sense. This is how humans work. So we are deep learning technique. So in summary, in very short, machine learning and deep learning is basically where it learns by itself, and there are multiple layers. So what you see in the deep learning, there are more filters, more and more filters, and it's able to predict between what it is. More data it comes, more decision you make, deep learnings get better. Whereas in the machine learning, you have either labeled data for prediction or unlabeled for clustering and so on, unsupervised. So this is a very short description of the AI. Now we talked about the security, we talked about the AI, that's all for AI. Now let's look at what is the behavior we expect from our security concept and why do we expect that, and then we will tie everything together. So if you look at advanced security concept, what should be our advanced security concept? And some of the things are very obvious. You probably don't realize that the very first one, continuous authentication. Why do you need continuous authentication? If you look at any system, whether you are logging onto your bank or to your enterprise account, you have authentication, authorization, username, password, two-factor authentication. Doesn't matter what it is. You authenticate once, and then both system assume that everything after that is great. Both are authenticated, but things can change, situation can change, your behavior can change. So we need to have a system that does continuous authentication, not one-time authentication. You know, it's like binary, yes, no. You are authenticated, that means you have open access. No, that is not the way to secure in this modern era of hyper cyber threats and attacks. So you need to have continuous authentication, and machine needs to look at your behavior, how you behave every day. And if you suddenly behave in some different way, the machine starts behaving, it's got to understand, hey, something is wrong, even though the system is authenticated, because you could be hacked or a malware could have inserted, and you are perfectly legitimate, great guy, fantastic, trustworthy, authenticated, paying your services, doing the legitimate thing, but unconsciously something could have taken over your system and doing weird things that you don't know. So we need to have this system of continuous authentication in advanced concepts. Second, micro-segmentation. If you followed our last webinars, we talked about secure enclaves with software-defined car. What it means is basically having domains, clusters with different security profiles. So the fact that you are allowed in one cluster for certain application doesn't mean you have unfeathered and free access to go everywhere in the vehicle or to something else. So very targeted, meaningful access, because a lot of the content and the access is coming somewhere outside of the car. It's provided by content provider or application provider or suppliers to the car maker or the OEM itself, and it's beamed down. So you want to make sure that that application is only accessing for what it is supposed to be. So you have to create this concept of micro segmentation within the vehicle. Dynamic policy decisions, very simple. Policy decision cannot be static. You cannot have firewall type of policy decision. Yes, access control, no, yes, no, or whitelisting or blacklisting or whatever you call it. Some kind of go, no go decision. It cannot be static. Things are changing, so you need dynamic, so you need to automate it. In order for it to be dynamic, you need to automate, and to automate, you need a closed loop architecture. Without that, you cannot collect what's happening, you cannot analyze, you cannot react back. So dynamic policy decisions are required in the software-defined car. And the last one that I have listed here is threat intelligence, and this is not about individual enterprise. Unlike enterprise security, this is not your threat only. This is our collective threat. We got to think about collective. So we need to have real-time sharing across the OEMs of all the threats that are coming together. We need to be able to do crowdsourcing. It's not about protecting an individual OEM or individual suppliers. It's about collective defense. Security is our collective defense, and we need to think in that way. And we need to create a system where we are not competing on that, but we are actually collaborating and creating a better security for the entire fleets of vehicles that are out there, irrespective of a make and model. And so therefore we need more real-time sharing and also the cloud sourcing. These are the changes that are not there today, and we need to implement that architecture in order to secure the future of the autonomous vehicle and software-defined car. Now that we talked about it, let's now bring the AI with this concept of advanced security concept all together, and bring it all together and see how it will fit. And this is just an example of how one could think about. At the left hand side, so there are some legend. First of all, the blacks are trained data. So on the left hand side you have the car, you have historical data, you have supervised learning. We talked about trained data, right? And then you have some outcome, and the outcomes are on the very right and bottom, like the historical breached security situation, the signature, the anomalies that you have detected, or the frauds those claims have. Those goes in there with the historical data, and you have made some decisions. So you come up with this algorithm, and that algorithm gets fed into the learning model. And now you bring real-time data, which is now not your trained data, real-time data, and then you use this algorithm to predict. And we talked about it in the machine learning, how machine learning works. This is exactly the focus of the machine learning based security update. So you use those things, and then what you are predicting is potential security breach, potential anomalies, potential fraud claims. And if you have a center that analyzes those threat monitoring, and then it can proactively make some countermeasure, whether it is a security patch or a new software update, and that is where closing the loop comes into place. That is the orange, that is the OTA update that goes back from there to the vehicle. So what you have done is, because the machine predicted a potential breach, you now are proactively making a security patch before it even happens. This is just the beginning of using AI to detect and predict threats and to take proactive countermeasures. This is how we need to think about the security for software-defined cars. So with this, let me summarize as what I talked about. And there are 5 key takeaways. 1, in vehicle architecture, we should think about 5 C's. What are those 5 C's? From chipset to the client to the cloud, which is cloud in the car itself, right? Or we call fog, which is your mini cloud in the car, or mini data center, or mini edge computing. Connectivity from the car to the outside world, the cloud, and the content, right? The 5 C's. So we got to think about the 5 C's of what security measures are we doing over there, and also think, that is one way of looking at it. The other way is to look at what are the different layers of function. One is around firmware layer, the 4 layers we talk about security stack. One about firmware, one is about software, one is about data and artificial intelligence, the other was as a user experience applications. We need to think about this 4 layer and think about the concept of micro segmentation, enclaves. How do you make sure that what is for firmware for a certain thing, that access does not get into the software or able to get into the artificial intelligence. So having that segmentation, micro segmentation, is very important. That's in vehicle architecture. We talked about, in order to have dynamic policy and decision making, you need to have a closed loop architecture, which is an ability to collect data, analyze those data, react back, and also the ability to provide new applications and services and new monetization model of delivering new things and entice the users in the vehicle with new application and services. And that's the concept of smart mobility services, but you need to also have a feedback loop. So the feedback loop is very important, and so that's the closed loop architecture you need to think about. Third, we talked about connector services. This is very important, as in the vehicle there are safety related things, there are entertainment related, infotainment related, navigation related. These are all different type of things. So and the access to those needs to be segmented. you need to provide access to the OEM needs to provide access to the partners, but they need to be isolated enclaves. Enclaves has to be created over there so that they only get that access. And this will allow you to get into connected services world without having to worry so much that something from the infotainment breached into your ADAS or safety system and vice versa. New business model. You know, as Shushev talked about, that we are getting into the connected car, right? And 250 million cars will be connected by 2020. But the security that we need for connected car, you may feel secure, but that is not going to guarantee what is going to happen for the car share, ride share. You need to think about providing human safety, security, stress-free from a trusted platform. So the platform that you create and the model, the business model that you have, you need to be open to that model of how to enable car share, ride share, car ownership, all those sort of things. But that platform, the OEM platform or the supplier platform that is providing these updates and everything, people got to have the trust that it is secure, it is keeping me safe. And your business model has to reflect that. It could be reward system, it could be cloud sourcing, you could have a lot of different ways to show the trust level. Trust is something that you have to earn and you have to maintain. And the timing. Timing is very important to make sure that how you're securing connected car is not going to guarantee for the car sharing or autonomous. In the car sharing, there will be many owners to a vehicle. There may not be key fobs, physical key fobs. It may be open through a smartphone or through facial recognition or biometric that is pushed down to the car. So the securing those are not securing the connected car. So we need to figure out the security approach for connected car, for car sharing, autonomous, and we talked about the way to think about it. If you think security from ground up in the comprehensive way, that is probably a better way than doing, you know, okay, we secure connected car, but then in the autonomous algorithms and so on. So how do we secure that? So it requires really getting the timing right for which level of security for what types of vehicle and that we are creating. So this brings me to the end of the key takeaways of the presentations. So I want to welcome back Shushev, and we can go into the Q&A sessions.
Thank you very much, Mahbubul. I think that was a very insightful session. That was a lot of material to unpack in 40 minutes, I think. You know, some of the thoughts that stuck in my mind from your presentation, the 4-layer architecture, I haven't seen such simple crystallization of thoughts. I think you presented that extremely well. I think your closed loop architecture, which also I think is something that Movimento brings in form of a unique selling proposition to the table as well. I think that was crucial. We hear so much about artificial intelligence. We hear so much about machine learning. I wouldn't say nobody, but it's very difficult to understand what is the hierarchy for all of that when it comes to this car and securing the car. So thank you very much. I think it was truly insightful for me as well, and I'm sure our audiences enjoyed it. So going forward, I think we want to do a quick time check. In terms of time, we have about 10 minutes. So we have a few questions that I think I'd like to see how many we can cover. To start off with, you know, security being the key aspect of this discussion today, do you believe that security is falling behind compared to the number of cyber attacks and threats that are happening today?
The answer, I believe, look at the statistics. Every day there is a government. Today the intelligence agency got hacked. The elections got hacked. So you keep on going. There is ransomware. Enterprises are not disclosing, but it's really happening everywhere. Whoever is not you know, talking about it because they don't want to make it public, but almost every IT organization will say that they are getting attacked from phishing and ransomware almost on a daily basis. So the level of sophistication of cyber warfare has increased, no doubt. So there is no doubt in our mind. The question is, our way of approaching is still the way of 2000. which is network centric, information centric, whereas the attackers has gone from application and all sort of different ways of looking at it, and they're giving you less and less time. When you have ransomware, they will say in 5 minutes you pay this money or I'm going to disclose everything. What are you going to do? They know that you cannot react within 5 minutes, right? So those sort of things. So they are playing with time, they are playing with agility, speed, and also new sets of applications that are coming in.
Sure. Like you said, the vectors are different.
The vectors are different. We need to be different from protecting
to respond to it. So how can the industry rally around a common threat defense system for automotive? I think luckily for automotive, it's coming late to the game in the sense we are already seeing all these vulnerabilities in the various industries. So from that perspective, how do you think the industry can rally around it?
So one thing is that it is well known that number one inhibitor for IoT, Internet of Things industry is security. It's any connected devices, the number one inhibitors for acceptance is security, because fear of security, right? That is nothing compared to the automotive security. It's about our life. Whereas a device, yes, you may have a downtime, I'm not saying you may have financial hit or your reputation can take a damage, but this is about our life. So what it means when it is about our life, we need to, it's our collective problem. So don't look at in isolation as I am this maker, you are that maker. We are humans, so we need to protect ourselves. So we need to have a common threat defense cyber crime branch or crime unit where we are sharing intelligence on the security level. So that should not be a differentiator. It should be, citizens should feel confident irrespective of which car they make. Just like today we have with the safety standards, that security is also has a certain standard. And the industry, I know automotive industry does always their best to go above and beyond what is the minimum required. Like they go for 5-star rating for safety. They don't have to, but they go for it. They go for the gold. So I think if we have for the security, they will all collectively, because the number of security experts are limited. So we have to bundle all these forces so that together we can address this industry.
So I think you almost answered my second question. Should individual OEMs solve their own security? Probably not. I think we should look at some kind of a structure. And what is the benefit of automotive OEMs coming together to collectively create a security model?
It's a protecting of our industry. If the humans lose trust in automated driving of one or other, then we all suffer. The whole value chain suffers. The whole industry doesn't take off. So it's growing the pie. So it's our collective interest to make sure we as an automotive industry compete on feature, functionality, and capability rather than security and safety. This should be no in terms of competition. This should be competition. Well, this should be actually collaboration, I mean to say.
Okay.
So OEMs have to figure out, and the auto industry has to figure out a cooperative model where they compete in some area, feature functionality, but they complement each other when it comes to safety and security.
So then, perfect segue for the next question. Should this be a public sector play, or should this be a private-public partnership, or what roles can nations play in this regards?
I think that this is something that has to be it has to be private public, because you need to have also government protecting its citizen. Government have a number one responsibility to protect us. And so if autonomous vehicle is the way, or that can put us in risk, then they have a key role to make sure they're protecting, because they have to answer to us as citizens.
Sure.
So on the other side, the business has to make money and have interest, and they cannot take on rogue nations attacks coming from somewhere else. So they need to harness the energy together. Right, so you have the private, which is the industry itself, working with the government, so that their checks and balances are very good thing. You know that.
Sure.
So every now and then government needs to look over, and then legislation can improve as well. Not that we want to live by legislations and laws, but they are very important to build a foundation of trust for the people.
But you see this will evolve in the next time, year or two time frame?
Oh, absolutely. You see already the US government already in the House of Representatives, they have already passed a bill for partial and full autonomous vehicle. The Senate has passed as well. So they are coming from the autonomous side, but that's the law. But the law itself, the law needs to be implemented and has to come up with a cyber, I wouldn't say crime, cyber protection or cyber defense unit for the auto industry. That would be a great thing to happen. I haven't seen that yet, but that would be a great thing to happen at a nation level, and then you could extend it to like-minded nations as well.
Sure. So another question more close to home for us, I think you talked about the 5C concept and also talked about computing and the content in a car. So what role do you see OEMs and tier ones and suppliers playing in the car in the VS in the cloud?
So obviously the data, right? When I talk about it, the data generates from the car. So one good thing is that faster you make a decision, more value you add, right? So the OEM and tier one actually are in an amazing position because their machines are generating data and giving all these things. So sooner they can react, and so with bringing the artificial intelligence in the car rather than taking the data to the artificial intelligence, right? Bring the intelligence in the car, make a lot of those decisions locally. But only local decisions are not going to help because you cannot, we talked about the cars are learning, right? From the experience. It cannot be that only your car is learning and based on how much you have driven. What we need is a way of all the car learnings disseminate to all the cars. So that while you are sleeping, there might be all the other autonomous car driving so many miles and new learnings are there. Those learnings are passed down to your car. By the time you wake up in the morning and driving, the car is more knowledgeable than it was the night before.
Yeah,
right?
More smarter, more democratization of that knowledge per se.
Yes.
Okay. So why should the client and the cloud cooperate? Why do we need the cloud for automated vehicles?
Well, I just talked about this crowdsourcing, right? And the ability to learn. If there's a black ice or if there's some something that some car has faced or some situation, we cannot say corner case because autonomous car, the situation is changing. Lot of different environments and geographic climate, all sorts of things. So we need to harness all the knowledge from all the cars, and without having that, it's very difficult. Second. So that's one thing. Just to keep the car safety and to make sure every autonomous car are almost at the same level, irrespective of how much mile that individual car has driven. It's very important. Second, when you use autonomous car, what do you do in the car? For me, is an example. When I sit in a train, whether it is in Far East, ultra-modern train, or in Europe where the train there's a Wi-Fi, there's a coffee, what do? You either browse or you do some productivity thing or you entertain yourself. So that means all those entertainment are coming from outside. So you got to have connectivity. So people, some are going to be doing meetings, some because you're not driving now, you have the time. So it could add time to your productivity, to your business hours. What it means that you will be connected, and so all these connected services are going to come in. Third, the economic consumption model to car sharing.
Okay.
Right? Car sharing will allow that a single car is shared by many people. So obviously car needs to know who is going to get the car now. So there has to be this connection between the human, the cloud, and the car.
Sure. So can we do a quick time check? How much time do we have?
2 minutes.
Yeah. So I think trying to summarize now, probably one last question. What is the relationship between data analytics and machine learning?
In a very nutshell, one is static, other is dynamic, self-learning, right? So it starts with analytics, but analytics cannot handle all the events and the alarms that are coming. So then you lower the bar to reduce the false positive, right? And then you are in a difficult situation. You cannot analyze. So what you need is, as the situation changing, you want the weight factors of this analysis algorithms to change, to dynamically change. So I would say that is the predictive machine learning is kind of what that model is going.
Okay.
So there is that relationship.
Excellent. So Mahbubul, thank you very much. I think we've almost run out of time. So again, I want to thank you once again. I think this was a wonderful session. I would be very happy to see what the responses from the audiences are. And I think we now have a good understanding of machine learning and how it plays a major role in securing the autonomous vehicle with AI and OTA updates. So I'd like to have everyone join the next webinar, which is saving lives using artificial intelligence and context-based automotive OTA updates on the 12th of December. Please register on the Movimento website. We look forward to interacting with you in the next few weeks through these webinars and emails. Thank you for joining us today, and see you all on the next webinar. Thank you, Mahbubul.
Thank you, Shashank.